Hey, hello, and welcome to today's GFG problem of the day. Reach the end point. Let's see what the problem has to say. There are end points on the road. You can step ahead by one or two if you start from point 0 and can only move from point I to point I plus 1 after taking a step of length 1. Find the number of ways you can reach at point N. So let's see through an example, right? If N equal to 4 and if there are, uh, yeah. So if there are, for example, after 0th point, there are 4 points, right? So what the problem is trying to tell us that we have to calculate um, number of ways to reach point 4, right? From point 0. Okay. Okay. So how we can reach point 4, right? So there are, so we can, so at given point, we can either move ahead by step 1 or step 2, right? So how we can go ahead? So one way is this or this, right? Right? One way is this or this, right? This way or this way, and from 3 to 4 this way. So what can be the number of ways, right? One way can be 0 to 1, taking one step at a time, right? Or we reach 0 to 1, then 1 to 2, then 2 to 4 directly taking two steps. Then one way can be 1 to 3, 3 to 4, right? And then another can be 0 to 2, 2 to 3, 3 to 4, and 0 to 2 and 2 to 4 directly. So if you see, there are 5 ways to reach point 4, right? When n equal to 4, right? So how we can solve this problem? So we can maybe go in reverse way, right? If f equal to 4, right? So what we can do using recursion, we can go one and two steps backwards, right? N minus 3, n minus, sorry, yeah, n minus 1, n minus 1, and n minus 2, right? Going one step backward and two step backward, right? And then n minus 2 here, n minus 3, right? N minus 3 and n minus 4. We can go on, right? Until we reach the base condition. And what can be the base condition? F of 0, right? And f of 1, right? So in order to reach point 1, right, it will be one way, right? And in order to be on point 0, right, when n equal to 0, right, when n equal to 0, it will be one way only to be on point 0 as well, right? Right. Now, what is the drawback of this approach, right? The drawback of this approach is it will be, the time complexity will be exponential, that is 2 raised to power n. Why? Because there are overlapping sub problems. Um, we are like calculating the same steps, right? To a point multiple times. So if you see fn minus 3, fn minus 3 is same, right? Fn minus 2, fn minus 2 is same. So due to which the time complexity becomes exponential, that is 2 raised to power n. Now what we can do to reduce the time complexity here, right? We can use dynamic programming, right? That is bottom up, right? So what we can simply do is, right, we'll take an array, dp array, right? Dp array, right? N plus 1, right? And what we can uh, store in dp of 0 and dp of 1, it will be 1, right? I have explained this earlier, right? Right, dp of 0 and dp of 1 will be 1, right? And then what we'll simply do is we'll start with int I equal to 2, I less than equal to n plus I. Okay. And simply dp of I will be dp of I minus 1, that is one step, right? One step. And dp of I minus 2, that is this second step, right? And simply will return dp of n, right? So yes, so this is a pseudo code, right? Not much difference in C++. This is Java, right? Only difference will be the declaration of the array in C++. It will be kind of dp of n plus 1, right? Rest the code will be same. Okay. So let's see the solution here. I've already, yeah, implemented. So only difference is that we are taking modulo because the number can be big. Modulo 10 to the 10 raised to 9 plus 7. Okay. So yes, this is a solution. Okay, it is accepted. Thanks for watching. Please like the video and subscribe to my channel. Thank you so much.